So here if you go for the next part of the discussion in that is the concentration of the ore. In the concentration of ore, actually we have four methods are there, as already we have discussed earlier in the flow chart. In the concentration of ore, as already we have discussed, that is crushing of ore, then hand picking, Froth flotation process, and magnetic separation. Among these four methods, Froth flotation process and the magnetic separation are the most important methods of the concentration of ore. Here if you go for the Froth flotation process, as already I told you, Froth flotation process is actually exclusively used for the purification of the mineral ore, the purification of mineral ore for pyrite mineral ores. Froth flotation process is the exclusive property of pyrite. It is the exclusive property of pyrite mineral ores. So this pyrite mineral ores, as you can see in the diagram, or as you can see in the figure here, we take a long sized vessel. In that vessel we fill sufficient amount of water and we just take one small T-shaped blower where it is punched with small holes, and when through this blower pipe we send compressed air into this blower pipe. After filling the pyrite mineral ore, after converting into crushed powder, that crushed powder is filled with sufficient amount of water. This is filled with water plus pine oil. Water plus pine oil. Water plus pine oil. This purpose of adding water along with pine oil is to create sufficient amount of foam or froth. This foam or froth is nothing but the plenty of soapy nature. That means lot of bubbles will come out in the form of a soap solution. So as the foam and froth, the level keeps on increasing. When we are trying to blow the compressed air into this blower pipe, more and more amount of oxidation takes place, more amount of aeration takes place inside, and you find all the froth and foam coming in the upward direction, moving in the upward direction. As the foam and froth moving in the upward direction, you find all the purified mineral ore particles of the pyrite mineral ores. They come to the topmost region of the vessel, and any impure particles are there because of their higher density, in the particle size. The impure particles, they stay back, they deposit at the bottom of the vessel, and the ore particles which are lighter, which have lesser density, they move in the upward displacement and they are finally skimmed off, or they are decanted off from the vessel. In this way, the impure particles, the impurities of the mineral ore particles and the purified ores of the pyrite ores, they are separated through this method because of the difference in the size of their density or the size of their particles. If you go for the magnetic separation, the advantage in this magnetic separation is, in the magnetic separation we take two electromagnets. These two electromagnets are fitted with the rolling belt, and we take a small funnel. In that funnel we take the crushed iron ore, the crushed mineral ore. Usually we take oxides of iron, because the oxides of iron, if you take the impurities of the oxides of iron, it contains non-magnetic impurity. Because it contains non-magnetic impurity, the crushed mineral ore, when it is rolling over the moving belt, that's rolling belt, you find that all the magnetic particles of the mineral ore, they form a separate heap. Here they form a separate heap, and all the non-magnetic impurities, they try to form another heap. They are separated through certain distance. In the non-magnetic impurities, usually here the best example is you can take, that is Fe2O3 hematite, Fe2O3 hematite which contains impurities tin stone, SnO2, tin dioxide particles, small tin dioxide particles are acting as impurities. These impurities, they separate out from the oxides of iron and they form a separate heap. In this way, because of the difference in the magnetic nature and non-magnetic nature in the particles of the ore particles and the impure particles are separated in the form of separate heap, and the magnetic particles of the mineral ore, they form another heap. And this is how we can successfully separate the ore particles from the impurities in the electromagnetic separation, and these two methods are very, very important. So the next topic under our discussion is extraction of crude metal from the mineral ore. So here, extraction of crude metal from the mineral ore, metal extraction from ore is directly proportional to its reactivity. First point. Second point, the method of arranging metals in decreasing order of reactivity. The method of arranging the metals in the decreasing order of their reactivity is called activity series of metals. If you go for the highly reactive metals like, that is, sodium reacts with oxygen to form sodium oxide. Balance the equation, take 2 oxygens, so take 2 here, take 4 here. Solid sodium, oxygen gas, sodium oxide solid. Similarly, you take calcium solid plus oxygen gas, gives rise to calcium oxide solid. So take 2 over here and take 2 over here. Take 2 over here and take 2 over here. Similarly, if you go for aluminium also being a solid, it reacts with oxygen to form aluminium oxide solid. Likewise, iron reacts with oxygen to form Fe2O3 solid. Zinc reacts with solid to form zinc oxide solid. So all these are moderately reactive and highly reactive. But if you go for the inert metals, noble metals like gold, silver, platinum, you can just see that gold, silver and platinum, if you pass oxygen, no oxidizing reaction. That means they are low reactive. They are low reactive metals. So some reactions they do not undergo, they cannot react with the oxygen, and the chemical reaction is not possible. So here gold is stable, silver is stable and platinum is stable, and when they treated with oxygen, they cannot give any kind of oxide of the metal. So it indicates that these metals are low reactive. But however, if you take sodium, calcium, aluminium, iron and zinc, because of their moderate reactive nature and the highly reactive nature, they are readily able to give their respective oxides. So in this way, by